Okay, class, we are going to study about chapter 5. So chapter 5 and will be about the studying about opposite idea of derivative that we have learned. So I'm going to build some concept in here, and then after we do the next 2 weeks, and then you are going to continue on your calculus too. So let's look at some basic concept, what is going on. So first we are going to study about what area and distance relationship on chapter 5.1. So we all know that distance is equal to rate times time. And if rate is hard to think, I try to think as a speed. So let's look at this example. Young is driving to LA. She took total 5 hours to drive 300 miles. So let's try to graph in here. If I want to graph the relationship between time and distance, so here's going to be time and here's a distance. So 0 time will be 0, and then after 5 hours, 1, 2, 3, 4, 5, she had a distance of 300 miles. So if I connect this one as a linear equation, that is going to be a graph between time and distance. If you think about this way, y is equal to mx, so you basically graph between x and y. Okay, so now, what if I want to change this graph, the relationship between time and speed? So I'm going to graph exactly same graph, but my x is a time and then y is going to be speed as a rate. Then how can I graph this one? That means from here, how can we find the speed? That will be our derivative. But since it's a linear equation, we can find this slope by just using slope formula. So if you just find the slope here, it's going to be 300 minus 0 over 5 minus 0. So that will give me 60. So the slope of the in time and distance relationship shown as 60. So m is a 60. And m is a 60, slope is a 60. That means, do you see that your rate is going to be 60? Why? If you solve for r, that becomes distance over time, which means whatever is going to, this case, miles per hour, exactly. So I found my speed, my rate, which is 60 miles per hour. So if I graph this one, is everywhere, do I have the same slope? Yes. So from 1 hour, my speed was 60. And then second hour 60, third hour 60, because it's a cruise control. So my speed was 60 up to 5. Okay. Then now I wanna see here what they're saying is distance is rate times time. That means length times width. So do you see as area? If I try to find the area, we multiply length and width. So here says distance has the same relationship as area, which is a rate times time. So if I multiply here, saying that 5 hours times my speed 60, so let's try to find the area of this guy. What do we get? We get as 60 times 5, that is 300 as a distance, because the rate times time is a distance. Like mx is equal to y in here. So I want you to see, if we have a first derivative function which adds a speed, then how we can go back to this direction, then we can find the area under, because here's a rate times time is going to be distance, length times width. So the area represents the distance traveled. So make sure that you see the relationship here to here. If you take a derivative, rate between derivative, then the slope you can put it here as your first derivative function. So this is your f, and this is going to be your first derivative function. That's all up to chapter 1 to chapter 4. Now we are going to study backwards. Then what does that mean? If I have a relationship between time and rate, time and speed, then when you try to find the area under the graph, under the curve, we usually say that, then that area represents your distance. So when you multiply it, that will get to this one. So I want you to see here to here, take a derivative, here to here, you find the area. And this we say as integral, that we call as an integral. Okay? So if I'm just using the example here, as you see that my equation will be y is equal to y is equal to 60x, or you can put it as d is equal to 60t, right? So if you take a derivative, we know that m is going to be 60. That's how we got this graph, because it's going to be linear graph. Then if you have a 60, what we're going to study, we are going to take antiderivative. This is derivative, so we call as this one the antiderivative. Then you will get the equation. How we get the equation? In order to get 60, you are going to guess. I'm guessing from 60x. If you take a derivative, you get that one. So this is going to be your integral. So that's how we're going to study. So there is in class activities, it's the same idea as this one. So I want you to actually break it into first 1 hour and then next 4 hours. So that means you are going to have 2 linear equations. I want you to try that. And then also with that speed graph here, it's going to be 1 here, 1 up here, and then find the area and get the relationship. And then check the answer with me. So let's look at my answer. When you look at this one, first 1 hour, my graph between time and distance was 1 to 20. So I just plot that point. And then what is the slope here? The slope is going to be here. M is equal to 20. That means your rate is going to be 20. Speed is going to be 20. Now, 1 to 20 through is going to be 5, total it drove 280, so where it's gonna get there is going to be 300, right? Because 20 plus 280, just don't forget. So if you want to find the rate, it's going to be 300 minus 20 over 5 minus 1. So put it into slope formula. So 280 over 4. So I guess 70 as rate in here. So my rate is 70 miles per hour. So I'm going to graph here. Earlier I used a different scale. I can do 20, 40, 60, 80, that's fine. So this time I tried to make this one as the same, just showing a little bit different way. So first one, I got this speed as a 20 first 1 hour. And then next 4 hours, I had a constant speed of a 70 in here. So if you want to find the area under, that's going to be 1 times 20 plus 70 times 4 hours. So total distance to travel is 300. So we can see that if you have a first derivative graph, then if you want to go back to your original, how we calculate is going to be under the area of the graph. And don't forget, so that's the relationship. This is integral, this is a derivative. This is a original, this is the first derivative, and if you have a first derivative, because antiderivative, which is the same as an integral, opposite operations, then you will get back to here. Okay, so main idea here is just you want to find the area. But now we are going to talk about a main dish, because think about in right this moment. If I'm going to start the car, then as soon as you start, and when you start it, ideally, does it make sense as soon as you start the car and then just starting 20 miles per hour? So this is just our basic little physics in here. And then on main dish, we are going to observe that first 1 second, because your car is going to be accelerated this way. So we are going to observe this graph and then see that how we're going to find the area under. Okay, so as I mentioned earlier on my main dish, we are going to talk about how about the when cars starting first 1 second. So if you think about cars starting first 1 second, we can actually put as our time and rate as a relationship of y is equal to x squared. So which means your graph of your speed is going to be accelerating, because each time it's going to be your speed is going to be faster and faster. So I'm going to put this one as an example of y is equal to x squared, some of the examples that we can use easily. So I want to observe first 1 second, and here we are going to see that if this graph looks like this way or it looks like this way, find the area is easy. But once it becomes some of the function like a quadratic, then we haven't learned how to find the area. So I'm going to show you in this section how we're going to find the area here. So let's graph y is equal to x squared, but only 0 to 1. So I'm going to zoom my graph to here. So this is going to be 1. That means everybody know that 1, 1 when you plug into t table. So 1, 1, and my graph is going to be something like this way. Okay, so here says I'm going to find n as 4. What does n as 4? which means we are going to make a 4 rectangles. 1, 2, 3, 4 rectangles, and then we using left side as our sum. So I'm going to build a height. Now look at mine carefully. This height, this height, this height, and the height. So I built a height here. Then from here, you are going to have a 4 rectangles. We are going to start estimate. Since we cannot find the area, so we are going to build a rectangle and then try to estimate. So we're using left side as a height. So if you have this line, that's going to be your base. And do you see that 1, 2, 3, 4? So we say n as 4. Then from here, left side is going to be your height. So this case, your height is going to be 0, right? And then this case, what will be your height? Because I know that this is 1 over 4, this is 2 over 4, this is 3 over 4. So all I need to do is plug in. If I plug in here, then my height is going to be 1 over 16. If I plug in here, that's going to be 1 over 4. If I plug in here, that's going to be 9 over 16. Okay. So what am I going to do is I'm going to draw from your left side as a height and then rectangle. In this one, left side is going to be my height. So look at, I'm going to draw the rectangle, but left side is going to be my height. So from here, that's my height. From left side of that rectangle, if you look at this one, this side, left side is going to be my height. So I'm going to estimate 1, 2, 3, 4 as my area. So if I see it, do you guys see that my base is 1 over 4 since it's divided into 4? Then height is going to be first case 0. Second case, my base is 1 over 4 and height is 1 over 16. Third one, my base is still 1 over 4, height is going to be 1 over 4. And then last one, I have 1 over 4, and then height is 9 over 16. Looks like 4, right? 9 over 16. So I have those 4 rectangles that I'm going to add. But when you add it, it's easier to factor it out. So 0 plus 1 over 16 plus 4 over 16 as a common denominator, 9 over 16. And if I add them inside, that's going to be 14 over 16. So we can reduce this carefully. That will give me 7 over 32. What I did, I reduced it. This one is a 2, this one is a 7, so I get 7 over 32. So I know that my area is definitely less than 1, and I got 7 over 32 for this area. So this method we call as left-hand sum. Left-hand sum of the approximation for integral. So now I want to show you exactly the same thing and how we're going to estimate the area using right-hand sum. And after that, we are going to basically take an average, and that will give us actually very accurate area under the curve of x squared. So same idea, we are going to have x squared graph. Then graph nicely, and now I'm going to build my height, and this is my 1, 2, 3, 4 basis, and n is 4. Since it was my whole domain was 1 divided by 4 gives me 1/4 as my base, and the base we call as a delta x. Okay, that's going to be 0.25. The delta x, the change over x is 0.25. So this time I'm going to build my triangle, my rectangle using right side of the height. So do you see that this is right side of the height? So I'm going to extend to the left side. This is my right side, so I'm going to have my rectangle in here. It's a little bit confusing first time, but I'm sure you will get it. Just focusing on I'm using right side as a height of the rectangle. So observe one by one. I'm going to add this 4 area. First one will be 1 over 4 times, this will be 1/4. So if I plug in, my height will be 1 over 16. Also, you could actually use this one because that will be repeating here if after you observe a little bit. This is 2 over 4. So my y value will be 4 over 16. Plus this space is 1 over 4 times my height will be 9 over 16 because number I'm plugging is 3 over 4. So height is 9 over 16 as x squared plus almost there. If I have a 1, then what is this height? That height is 1, right? Because how I know? I plugged in to y is equal to x squared. So I got those height in here. Then if I'm adding carefully, that will be 14, and this is a 16 over 16, right? So 16 plus 14 is 30. So I get 30 over 16. And if I reduce, you can reduce this way too, right? So 15 and 8, I get 5 over 32. Oh, what did I do? 15 over 32, right? So I got left hand sum as a 7 over 32, right hand sum as a 15 over 32. But do you see that this is underestimated? This one is overestimated. So I'm going to add these two numbers. And then I want to find the average that will give me very good exam answer of this one. So if I want to find the average, that will become 22 over 32. So I will get, and then divide by 2. So that will be, divide by 2 means multiply 1 over 2. So I get 11 over 32 as the area. 11 over 32. As you see, this is definitely less than 0.5, right? Less than 0.5. And for fun, let's see what we get. Oh, of course, 11 over 32 is not an answer. And I will show you what the answer is. So the answer for this one, we estimate as a 0.34. 0.34375. That's what I got. But as I said, if we know this equation, we will be able to take antiderivative. So look at this one. It will pop up in next section. So I have an x squared. Then you have to guess what will be my original function. I know that they came from x cubed, right? So look at, I will just show you this time. The answer is 1/3 x cubed. Just take a derivative. Do you see that if you take a derivative, you get this one? So this is the answer of the antiderivative. And if I want to find the area, what we do is 0 to 1, and then x squared. If I take a derivative, 1/3 x cubed from 0 to 1. So we are going to plug in here, and this calculation is 1/3 plug in 1 minus 1/3 plug in 0, and then between that we subtract. So if you take this calculation, you see as 1/3. The actual real answer of the area under the curve of the x squared is 1/3, which is a 0.33333, and that is our estimation just using the box method. And this is the way they actually started estimating the area in 17th century, 16th century, until they discovered the calculus. That's why calculus is really powerful, because before the calculus, they had to find all the area, just estimating, making all those small rectangles as much as they can. So now, in class activities, you are going to do exactly same one, but instead of you having 4 rectangles, I'm going to have you to do 8 different rectangles. Your domain is still 0 to 1, but instead of using 1/4, you can use 1/8, 2/8, 3/8, 4/8, all the way to 8/8, and then try to plug in that number to get the height, and then just to do the same thing with one more of the rectangle there and compare answer with me. Okay? Okay, class, let's look at my in-class activities. Just to do one time, then you will probably understand a little bit better. So this time I divide into 8, which means my base will be 1/8, because 1 divided by 8. And then my height will be using the left side, and then square as y is equal to x squared. So 0 squared is 0, 1/8 squared is 1/64, and 2/8, the height is going to be 4/64. So we have 1, 2, 3, 4, 5, 6, 7, 8 rectangles. So I pull out vector 1/8, and then I add them everything. Then I get the number here. So finally 35/128. That is 0.273. So this gives me 0.273. And then that was my left hand sum. But in order to do right hand sum, I kind of use the previous one, because I know that first this guy is going to be repeat. First is 7, so I copy first 7 of them, and then after that my last height will be 1, because 1 square will be 64/64. So I add that one. So 1, 2, 3, 4, 5, 6, 7, 8. I want you to understand what is going on. And So from here, I add 1, and that is going to be 51 over 128 as a decimal 0.398. So right hand sum with 8 of them, I got 128, and then that is 398. So I average these two numbers here and divide by 2. Then I got 0.335. So if I average, it's going to be 0.335. So earlier I showed to you how we do it with integral. That's we're gonna learn next section and next section. So don't worry yet. But the actual number was a 0.333. But if you compare to previously with n size of 4, n size for left hand sum, n size for right hand sum, and then n size of 8 right hand sum, n size of 8 of a right hand sum. And as you see that whenever you have a bigger n, which means n is 8, earlier we had n as a 4, later on we are going to set n as infinity. Then what is it going to look like? It's going to be an illusion of look like just the graph. I will show you the graph, the figure right after. Then that's how we are going to estimate the graph. So later on we're going to do same thing in here, and then we are going to send the limit instead of n as a 4 or 8, we are going to set n as infinity. Then whenever you have so many those rectangles, then it is going to look like the area underneath. So let me explain to you on the dessert part, and then we can continue some thinking together. So this is a graph I tried to explain to you. Earlier we had n size of 4. If you look at this one, that's going to be more n size of 2. Do you see that from here? And then next one, they put it as an n size as a 4. 1, 2, 3, 4 in 1. And then whenever you have n size gets really, really big, like infinity, then as you see, our estimation is going to almost look like a curve. If you put so many of them, then we can see that we can assume as our area. So that's the idea we're gonna use. So let's look at the dessert together. So let's look at our dessert. If you look at our dessert in here, we wanna see the data, and then they gave me the relationship between time and velocity of the plane travels down the runway and try to take off. How far did the plane travel in first 10 seconds? So they gave me this time every 2 seconds, so that I'm going to plot those points as you see. So try to see that these are the points of x and y values. Then I want to find the left hand sum. So from here, build a height. Then how many n size I'm going to have? 1, 2, 3, 4, 5. So I'm going to have 5 as my n size. Then I said left side I'm going to use as a height. So this is going to be height. This rectangle, left side is going to be my height. So this is going to be my height. This rectangle, left side is going to be my height. And then if you're confused, just look at my figure carefully. So this rectangle, I'm using left side as my height. So let's try to find the area here. So first one, this is going to 2 times 0. And the next one, 2 times, what's the height? 99 plus 2 times height 140. Are you getting there? Understanding okay? 2 times 171.5 plus, since this is the last one, 2 times 198. So if I want to find the area under this curve to find the distance to travel first 10 seconds by estimation, we can add these ones, and that will get me 2 times all those numbers. Let's add them. So 299 plus 140 plus 171.5 and 198 gives me 608.5. So all together I get 1,217 feet for first 10 seconds. Okay, so that was the left hand sum. Then let's try to find the right hand sum. Do you guys want to pause and then try your right hand sum? Okay, yeah, so I want you to pause and use the right hand sum. Build the rectangle, and you can also use some of the information here like earlier I used. Here's a 1, 2, 3, 4, 5 rectangles. So try that. Okay, class, did you get 1659.8? Then very good if you got it. If not, just look at my work. I borrowed this number up to here and then I add this part. So that's how I got. And then I took the average of those two numbers to get the my estimation of the total plane traveled. Okay, so it's going to be just a fit. So now let's analyze it. Left hand sum. Is this going to be overestimated or underestimated, class? Do you see that this will be underestimated because your graph is actually right here, but it's estimate under. How about this one? This will be definitely overestimated. That's why we are taking the average. But did you guys notice that, Youngah, instead of using the rectangle, can we use a triangle? Do you see that? Like, can you use like triangle, or we call it a trapezoid method, like this? And yes, you can use that one, and you guys are gonna learn that in Calculus 2 class, okay? You can do that we call it the trapezoid method. And Youngah, can I just use the midpoint? Can I just use the midpoint instead of using the left hand sum and right hand sum? Yes, you can use a midpoint like this one. So instead of using the height of 1 or 2, you are going to use the height of the middle number. So if you're using middle number, that's going to be 7 and 7. And then if you add those rectangles, also you will be actually getting exactly same answer as this one. Why? Because that's the average. If you look at it, it's going to be average of the value you got here and here. That's going to be half. Here and here, that's going to be half. So there will be another ways that you guys are going to learn, which will be midpoint sum, and then also using the trapezoid in Calc 2. So just understand this part, and then let's look at last example. So let's look at this last question, almost there, and this is from our textbook example. So particle moves along the y-axis with the velocity 30 centimeter per second for first 5 seconds, and then next velocity is a 10 centimeter per second for next 5 seconds. Positive velocity represents upward motion, negative represents the downward motion. We talked about the rate or speed or velocity. Opposite sign means opposite direction, right, in the motion. So what is represented by the sum? So let's look at here. I'm going to do first 5 seconds. So starting from my graph here, and then next one. So they said that the speed is 30 centimeters. So 30 centimeters first 5 seconds. And then next one was negative 10 as the next 10 seconds. So I want to see this one and this one in here. So what does this number of sum represent? So I know that the x is the time, y is the velocity, then the area will represent the distance, right? So distance traveled. So the distance of the motion went upward and then downward. So distance of motion. Then let's calculate 30 times 5 is 150, and then 5 times negative 10 is negative 50. So what did I get? I got as total 100, and while with the unit 100 centimeters. Okay, now I want to discuss those two things in here. What is the total distance of this object traveled? Total distance. Total distance will be first 50 going upward and then next 50 going downward. So total distance traveled was 200, like a mileage. Total distance. But why did we get only 100? Because if there's A to B, like this, some people can do detour. Then mileage was 200 centimeters, but displacement, which means just A to B to the shortest distance, that's we call the displacement, is going to be 100 centimeters. So you have to be very careful. If you want to find the total distance, then you have to take the absolute value and then add it. If not, they are going to cancel out this part of the travel. So I want you to see by example 4 what they exactly meant. This meant as a displacement, just A to B, what is the shortest distance, which was 100. But what is the total distance to travel, or what is the gas that you need to buy for? You need to buy for 200 centimeters to travel then 100 centimeters, right? So I want you to see those two meanings, and that's it for today of chapter 5.1.